Hi guys, today will be our last new video of the whole chapter. After this, you will only have review assignments and maybe some more practice quizzes to get us ready for our test next week. In this, our final video, we'll be focusing again on linear inequalities. But this time, I'm going to give you a graph, and you're going to need to figure out what the original inequality was. Here is our first example. So as you can see, I've graphed an inequality. We can tell it's an inequality because it has shading and it's a dotted line. And our job is to figure out what inequality gave us this graph. To start with, we should decide what form we would like to write our answer in. And the easiest form to write your answer in is slope-intercept form. So that's what I'm going to be going for. I'm going to try to write something in slope-intercept form. To write something in slope-intercept form, we need two things. We need the slope and the y-intercept. I always find it easiest to find the y-intercept first. The y-intercept is where it's crossing that y-axis, which is at 0, 2. Now, if I can find a second dot, then I can count for my slope. So here is a second dot on my graph. When we're counting slope, we count rise over run. So from the left purple dot to the right purple dot, I'm going to rise -2 and run +2, and that simplifies to the number -1. So my slope is -1, and that gives me the equation y equals -1x plus 2. Now, I'm not looking for an equation in this problem. I don't want something with an equal sign because, again, I have some shading, I have a dotted line. I don't even want an equal sign at all with a dotted line. So now we're going to take it that one step further, and we're going to try to figure out what the inequality is. To try to figure out the inequality, it's best to pick a point in the shaded region of your graph. And the reason why we want to pick a point in the shaded region is because any point in the shaded part is going to give us a true statement. And it's nice to think of things in the true format. Lucky for us in this problem, we have the origin is in the shaded region. That means that if I plug 0, 0 into this equation here, I should be able to create a true statement using an inequality, a less than or a greater than. It's not going to be equal since this dot is not on the line that was drawn. So let's try it. I'm going to put a 0 for my x and a 0 for my y into this equation. And instead of an equal sign, I'm going to put a blank space so that I can fill in an inequality. Okay, so here is my new, it's not an equation anymore, my new math statement. And I'm going to simplify the right-hand side into just the number 2. And again, we decided since 0, 0 is in the shaded region that I want this to be a true statement. Notice it's not going to be an equal sign like we had earlier. 0 does not equal 2. And so the inequality we're going to choose is a less than symbol. Since this is a dotted line, we are going to leave it just a less than symbol. We are not going to put or equal to because it is not a solid line. So the last thing I need to do for my final answer is I need to erase this equal sign over here and replace it with a less than symbol. And so here in my purple box is the final answer to this problem. If I were to graph that inequality, it should give me this red graph that I have. Let's do one more together just to make sure we all understand what's happening. Again, I'm going to write something in slope-intercept form because that is the easiest format to write given a graph. For slope-intercept format, I need my slope and my y-intercept. I like to start with the y-intercept. It's a little bit easier. So this is crossing the y-axis at -1. Here's my next dot. When you're looking for your dots, make sure that they're crossing on the intersections so that it's on a nice whole number. And my slope from my left dot to my right dot is rising 3 and running 2, so 3 over 2. And here is my equation. Now, if it was just the solid line, which it is a solid line, if it was just the solid line, then I would stop here and I would say that's my equation. But to get the shading, we also need an inequality. We need a less than or a greater than. In this problem, I will not be choosing 0, 0 for my test point because 0, 0 is in the white space. It's not in the shaded region. And so 0, 0 would give me a false statement, and it's a little confusing to try to purposefully create a false statement. So instead, I will be taking a different ordered pair, again, somewhere over here in the shaded region. Looking at the equation that I have to work with, I'm going to choose an ordered pair with an x-intercept that can be divided by 2 so that I don't have to deal with any fractions. If I choose an x coordinate that can be divided by 2, then the fraction will go away and I can deal with whole numbers. Makes my life a little easier. I also want to make sure that my dot is not on that red line at all. And so I don't want to get too close to the red line just in case, just to play it safe. So the dot that I chose is all the way out here. And the ordered pair for this dot is 4, 0. Now, again, you don't have to pick an intercept if you don't want to. I could have just as easily have chosen like 4, 1 or 6, 3. Again, I'm choosing an x-coordinate that can be divided by 2 so that the fraction will go away, and I need something in the shaded region. Now, you have to be a little bit careful when you're plugging these numbers into the equation, especially since they're not the same number. The first number is your x-coordinate, and so that needs to be put where the letter x is. And then the second number is the y-coordinate. So you can't just pick them up where they are and put them in the same order. You do need to make sure you're plugging them into the right variable. So I'm going to put a 0 for the y over here, and I'll put a 4 for the x over here. Again, we're replacing that equal sign with a box so we can figure out what the inequality is. When you're simplifying the right-hand side, you can do 4 divided by 2 is 2, and then 2 times 3 is 6, and 6 minus 1 is 5, or you can use a calculator. But I chose a number that works nicely. I now have a math statement that I need to make true since I have a ordered pair in the shaded region. And so to make this true, I need to say that 0 is less than 5. Now in this problem, with my nice solid line, I want to also say or equal to. So not just less than, but less than or equal to. And that's what gets me the solid line instead of that dotted line from the previous problem. For our final step, I'm going to replace this equal sign with a less than or equal to, and then I have my final answer. And again, this is our last new lesson for Chapter 2. From here on out, everything will be review assignments to get you ready for next week's test.